So this video is just about what is slope as it relates to a linear function and how we can find it on the graph, in the table, and in the equation. What is slope? Well, slope is how much is being added or subtracted each time, and linear functions have a constant adding number or a constant subtracting number. In this case, if we looked at, there are 5 tiles in this one, and there's 9 in this one, because each time the figure number grows, we're getting 4 more. So we have 9, 10, 11, 12, 13 there. The slope in this case is 4, because we're adding 4 each time. And so the slope is always right in front of the variable. And in this case, we could go backwards to the 0 term, which would have just 1. But here's our slope. It tells you how much it's growing each time. Slope is how much is being added or growing each time, and we can think about it in terms of word situations as well. So we have $15, but I'm dropping $3 a day. So my slope there is going to be -3 because I'm losing $3 a day. And if we're writing it in an equation, you could either write it as my original amount is $15 and I'm subtracting 3 for every day. So this 3 for every day means that on the first day I'm going to lose $3, and I'll be right down here first day at $12, and then I'll be down 3 more. On the second day I'll be down to $9, and then on the third day I'll be down another $3 to $6, etc., 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 until I'm out of money. But I'm dropping 3, and that's why it's in front of the x, because the x stands for day 1, day 2, day 3, day 4. And you can write this equation either as I've got 15 and I'm taking away a 3 for every day, or you can write it in a more traditional way where you've got the slope times the day and then add it to the y-intercept. So both are absolutely correct. And notice that this is a negative situation and the line shows a negative drop. We read lines from left to right just like we read a book. And so if it's negative, if it's falling down, negative slope. So here we did this in class, but just a little reminder, I'm going to blow this up. Rise over run. So this particular one here, A, has a rise of 4 and a run of 2. So you can write that as 4 over 2. We could have also drawn the graph, drawn the triangle right there pretty easily, showing that it's also equal to 2 over 1. This one is 4 over 4, rise over run, but you can do 1 over 1, 2 over 2, 3 over 3. They all equal 1 for every 1. And then this last one is a rise of 2 for every 4, 2 for every 4, and we also could have drawn it right there, and we would have gotten 1 for every 2, the simplified version. So A is faster, it's a steeper line, but you also notice that the number that it's growing by, its slope, is higher than the other one and the other one. So 2 is bigger than 1 is bigger than 1/2. If you are finding slope from a table, you're going to go ahead and look for the change in y divided by the change in x. So you can look at it and go, okay, well, this one's growing by dropping 3. That's the change in y. And it is going up 1. So the change in y is -3, and the change in x is +1. So this one has a slope of -3, or -3 over 1. What if they're not right next to each other, though? Like this one's -3, -2, that's just jumping by 1. We're going to look at another example where it's not like that. But you're still going to be looking like change in y. So finding the slope from the table, still thing. We're going to change in y, change in x. So we're going to look at the change in y. This one is dropping by 3. The change in y is dropping by 3. And then here, it's growing by 3. So the change in y compared to the change in x is dropping by 3 for every 3. that means it's dropping 1 for every 1. So the slope here is -1. If you wrote it as -3/3, that's fine. It's just not as easy to understand as -1 for every 1. So the slope on this one is -1. We'll talk more about all you need to write the equation is the slope times x plus the y-intercept, and you're done. We'll talk more about that later. Finding the slope between 2 points on a line. If you're given a graph, you can graph the 2 points and make a slope triangle and do it that way, or you can go ahead and make a table. I'm going to show both ways. So if it says I'm finding the slope between these 2 points, I'm going to go ahead and blow this up so it's easy to see. I'm going to graph the 2 points. 5, 1 means go out 5, up 1. Here it is. And the 2, -1 is out 2 and down 1. So I'm going to go ahead and connect my points. And then it's pretty easy to draw a slope triangle. Right there. Like, okay, this one goes up 2 for every 3. Rise over run. So this one has a slope of 2/3. I can find the exact same number by just making a table. So if I didn't want to graph it, this is the graphing method, then we're going to go ahead and look at just using a table. So if I'm just using a table, I'm just going to make myself a table with the 2 numbers that I've got. And I'm going to look for the change in y over change in x. Here we go. Change in y, it starts at 1 and goes down 2. So that's -2. And then this change in x, it goes down 3. Down 2 and back 3 is the same thing as up 2 and over 3. So these are the same thing. -2 divided by -3, or negative rise and a negative run are the same thing as positive. So this one has a slope of 2/3. Once you figure out how fast a linear situation is growing, if you were writing the equation, and the basic form of the equation is y equals mx plus b, and m is always how fast it's growing. It's always the slope. Always, always, always. Because the slope is always multiplied by x or d or n, because that's what you're adding over and over and over again, d or x or n times. So, for example, when we're talking about me spending money, if I spend money for 4 days, I'm starting with a $15, and then I'm going to subtract 3 and subtract 3 and subtract 3 and subtract 3 4 times. So that's my 4th day. So it's 15 minus 3 times 4. If we're talking in general about the rule of me spending money, $3 a day, starting with 15, then it's going to be 15 minus $3 for every day. So x stands for the number of days. If we're talking about the tile patterns that was growing by 4 each time, it's 4 for every figure that's grown plus that 1 extra one. So once again, the slope is always the one in front of the variable.